Hi everyone, welcome to this class on spherical mirror ray diagrams. So we are going to learn in this class how to draw the ray diagrams for concave and convex mirror. I'm going to show you the tips and tricks on how to get these ray diagrams right. We'll look at the light ray rules and I'm going to make it super easy for you. So keep your pen and paper ready and let's dive right into this topic. Now before I begin, I want to say that do check out the other courses on our website. We have physics, chemistry, biology and maths for CBSE class 8, 9 and 10. So guys, if you haven't taken the other subjects, do take them and please do share it with your friends. For ICSE students, we have physics, chemistry, biology and maths courses for classes 8, 9 and 10. Once again, do share out our courses with your friends. And if you want to learn coding, we have Python programming, we have Java coding. These are great programming languages to learn coding, and we have physics and chemistry for the Cambridge IGCSE, which is the international board. So do share out our courses with your friends. Make sure you have subscribed to our YouTube channel. You can also follow us on Facebook and Instagram. So stay connected and keep learning. Let's first look at the light ray rules for spherical mirrors. Remember, there are two types of spherical mirror, concave mirror and convex mirror. So what do you think this mirror is? That's right, this is a concave mirror because it's like entering a cave. You can see this is the back reflecting portion, and this is a convex mirror. It is bulging outwards. So this is where the light ray falls, and concave mirror, remember, is a converging mirror. This is a diverging mirror. And then you have these important points of the mirror, which is the pole is the center of the mirror, C is the center of curvature, center of the circle or the sphere. And please remember to mark the focus exactly between P and C. So if this is 3 centimeters, this should be 3 centimeters. If this is 2 centimeters, this is 2 centimeters. So remember, focus should lie exactly between P and C. And what is this line joining P, F and C? That's right, it is called the principal axis. Similarly, here if you look, this is a convex mirror. So this is pole is exactly the center of the mirror. C is the center of curvature. So if you join the, it's part of this circle, and focus again is lying exactly between P and C. So make sure you guys draw these diagrams as we had discussed very carefully. Draw the spherical mirrors using a compass and make sure your focus is exactly between P and C, and you join this line which is called the principal axis. Now let's take a look at the light ray rules. For example, if a ray of light is falling on the mirror, how do we predict where it will go? And this is very important because we are going to use the light ray rules to predict the position of the image when an object is placed in front of these spherical mirrors. So let's take a look at the light ray rules. So here's first the rule number 1, where we are going to do together for a concave and convex mirror. So to make it easy for you guys and you'll remember it better, and we are going to start with rule 1, where the ray of light is parallel to the principal axis. Can you see? It's drawn parallel to the principal axis. And this is the pole, center of the mirror. This is center of curvature. Focus is exactly between P and C. And similarly here for a convex mirror, P, F and C. So now where does this ray go? If the ray is drawn parallel to the principal axis, rule 1 says that after reflection for a concave mirror, it is going to pass through the focus, because this mirror converges the light rays through the focus. So please draw that right now. The ray of light parallel to the principal axis after reflection passes through the focus of the concave mirror. Now in a convex mirror, what will happen? The ray of light which is parallel to the principal axis after reflection, will it go like this, passing through the focus? Is this correct? No, because the mirror is not transparent, light cannot go through it, mirror is opaque, it is a reflecting surface. So the light is going to reflect off as if it was coming from the focus like this. So there you can see the light seems to be coming from the focus, and this is for a convex mirror. So there you can see the difference. Here the light is actually reflecting and passing through the focus, which is why this is a real focus. Here the focus is virtual because it appears to come from the focus. So this was rule 1. Now let's look at rule 2. Rule 2 is a very interesting rule where the ray of light is passing through the center of curvature of the mirror. So there you guys can see that it is passing through the center of curvature C, or here it is going towards the center of curvature for a convex mirror. For a concave mirror, it actually goes through the center of curvature. So this is a very interesting rule, because very simple, that when the ray of light passes through the center of curvature, it will simply reflect and retrace its path. So the ray of light is just going to go back like this, just retracing the same path. Same thing for a convex mirror. When it is appearing to come towards the center of curvature, after reflection, it just retraces the path. That's it. Now, why is this happening? Why is it retracing the path? This is very interesting, because remember, circle, there's a theorem that if you join the center to the perimeter of the circle, what are you drawing? Radius. And if I look at just this part of the mirror, a curved mirror is made up of small, tiny plane mirrors. So this part is like a tangent. So I'm drawing a tangent to this circle. This is like a tangent here. And we know that the radius is going to be perpendicular to the tangent. Radius is always perpendicular to the tangent. That is why you can see that this ray of light is acting like a normal. When you have normal incidence, angle of incidence is 0, angle of reflection will be 0, because when you have light incident normally, it will simply retrace its path. Same thing over here, that if you look at this, if you draw a tangent, the small plane mirror here, then it is perpendicular to the radius. Once again, we are having normal incidence, so it is simply going to retrace its path. So this was rule 2 for concave and convex mirrors. Rule number 3, what is the third rule? Third rule is when ray of light is passing through the focus for a concave or appearing to go towards the focus, because again it can't go straight through. Mirror is opaque, it is not transparent. So let's say here the ray of light is passing through the focus here of the concave mirror or going towards the focus here. So now what's going to happen? So this is like the reverse of rule 1, because remember in rule 1, ray of light parallel to the mirror or parallel to the principal axis of the mirror passes through the focus. So what if I retrace, I reverse the light? If I make the light go through the focus, what will happen? It will become parallel to the principal axis, because remember the path light is reversible. It's called reversibility of light. If light goes this way of a reflection, it will retrace back the same path. So rule 1, if you turn it around, it becomes rule 3, that light going through the focus will become parallel to the principal axis. As simple as that. So what's going to happen here? Ray of light passing through the focus after reflection becomes parallel to the principal axis. So this is what's going to happen. There you go. So after reflection, it becomes parallel to the principal axis. Similarly here, ray of light passing through the focus after reflection is going to become parallel to the principal axis. There's our answer. Clear? So you can clearly see rule 1 and rule 3 are reverse of each other. Rule number 4. What is rule number 4? If ray of light is directed to the pole, which means it's exactly the center of this curved part, the spherical mirror. So if it is directed towards the pole of the concave mirror or the pole of the convex mirror, what will happen to this ray of light? So now we learned that if it is hitting the pole, then once again this principal axis is acting as a normal, because it is passing from center of curvature to the point of incidence. So now it will follow like a normal law of reflection. The ray of light will be reflected like this, where angle of incidence will equal to angle of reflection. So let's say this angle is 20 degrees here. After reflection, the angle will be 20 degrees. So it will follow like it looks almost like a plane mirror diagram, where because basically spherical mirror follows all the laws of reflection, and in this special case the principal axis is acting as a normal. So there you can see if angle of incidence is 20 degree, angle of reflection is also 20 degree. So here you can see angle I is equal to angle R is 20 degree. Clear? Can it be 0 degree? Well, then it will become rule 2. If the ray of light is passing through the center of curvature, obviously it will bounce back. So there you can see this is the rule. And similarly for a convex mirror also, let's say this angle is 30 degree. So it will bounce back off the mirror, making the same angle of reflection as the angle of incidence. Important thing to realize is why are these angle of incidence and reflection here? Because this is our normal. It is perpendicular to the point of incidence, the line passing through the center of curvature, which is the principal axis here. Once again here, so there again you can see angle of incidence is equal to angle of reflection is equal to 30 degree. This is rule number 4. Now one very important point here, that when drawing ray diagrams, which rule should we use? Do we have to use all the rules or only some of them? So that is one very important thing, that which you have seen in plane mirrors also. To produce the image of an object, what is the minimum number of rays that you guys need? Can you guys tell me? If you want to form an image of an object, what is the minimum number of rays that you need? Very good. The correct answer is 2 rays, because if you just have 1 ray, you're just getting the light path, but object is usually, having a certain height or length, right? So you need 2 rays, right? And you need the 2 rays, and we usually take it from the top of the object and see where they intersect to form the image. So like you have seen in my videos, the minimum number of rays that you need to form the image is 2. So therefore, how many rules do I need to use? Only 2 out of these 4 rules. You don't need to use all the 4. So we need to use only 2 out of 4, but which one should we use? I would recommend to use rule 1, 2 and 3. Do not use rule 4 unless it is necessary or you get some direct question like here, because this relies on measurement of angles. To draw the reflected ray, you have to measure these angles very accurately, because if this is 20 degree, you have to measure with the protractor 20 degree accurately and draw the ray, and measurement with the protractors are never super accurate. Okay, so please avoid using rule 4. So I'll write this important note here, avoid using rule 4. So that's something very important for you to remember. And then of course I have this random ray rule, where basically I'm just saying that if you given some random ray like this, which does not pass through, it's not parallel to the principal axis, doesn't pass through pole or center of curvature or focus, then what do you guys do? How do you draw where will this ray go? Then the interesting thing is that now, since this is a curved mirror and it follows laws of reflection, so we really have to measure the angle of incidence and then draw the reflected ray according to that. But how do we measure the angle of incidence? Remember, the angle of incidence is always measured with respect to the normal. So the question is, where is the normal here? This is your light ray. To use that angle I equal to angle R, you need the normal. How do you get the normal? Very simple. Just join the point of incidence, let's say this is the point of incidence, to the center of curvature. So very good. That is the only thing you have to remember, that if I join the point of incidence and the center of curvature, let's call the point of incidence O here. So if you join OC, you have basically drawn your normal. Why? Because this is like the radius. So once again, it's perpendicular to the tangent drawn over here. So this is my normal, and now you can easily draw the reflected ray. So first you measure the angle of incidence. Let's say this angle turns out to be 30 degrees. So now you draw the reflected ray, which makes an angle of 30 degrees with the normal. Done. So this is not really a rule. This is, I should say, random rule technique. Okay. So maybe we can call this random ray. It's more like a technique here. And the whole technique relies on drawing that normal. After that, now you have to measure the angles here with the protractor. So you can't do anything. But typically, you will not use this kind of stuff. You will only use 2 out of the first 3 rules. And same thing here. For a convex mirror, what will you do? Same thing, that you are basically going to draw the normal here, right? So that's what you're going to do. Yes? So once again, you have your pole, you have your focus and center of curvature. This O is the point of incidence. So go ahead and join O and C to form your normal, and just extend OC. There you go. So what is this angle? Let's say this angle now is whatever, 30 degree or whatever angle you're getting here. And then after reflection, this is going to make the same angle of reflection here. So there again, same, join the normal, angle of incidence equal to angle of reflection, and you're done. So now let's come to our important thing. Again, please make sure you guys watch the other videos in this chapter. So how to find the image? Because in a plane mirror, it is very simple, right? If instead of a curved mirror, you just have a plane mirror, then we know object distance equals image distance, and you can actually cheat and plot and object height is same as image height, so you can easily get the image here. But here it is not the case, right? You cannot say object distance equals image distance, object height equals image height. Will this be correct? No. So that is why to predict the image here, we need to use the light ray rules. And as I said, 2 out of the first 3 rule. Avoid using that pole rule, and random rule was just a technique. Because sometimes they may say complete. So why did I teach this thing? Because sometimes they say complete the ray diagram. So you have to use this technique of joining OC and drawing the diagram. So let's go ahead and try it out, guys. So let's say you have an object like this, and let's mark the object as AB. And once again, like we discussed in the previous class, make sure you're drawing this with a compass and your focus is exactly between P and C. So if this is 3 centimeter, this is 3 centimeter. Make sure you guys do that. So let's mark the center of curvature, the focus, the pole here, okay, and make sure these are equidistant. So if this is 3 centimeter, this is 3 centimeter. Now to find the image, remember we have to draw the rays, and the important thing is draw the rays only from the top of the object. What will happen to the base or the bottom of the object, I'll show you, but please draw the rays only from the top of the object, which we can call as A. So we need to draw 2 rays to determine the image of A this side. So which rule do you want to go for? One of the simplest rule is rule 1, where you can draw a ray parallel to the principal axis. After reflection, it will pass through the focus. So let's do that. So ray of light parallel to the principal axis, and we know this concave mirror is converging mirror. The focus lies here, right, on the left hand side. So it's going to pass through the focus. So see, after reflection, so there you can see that's how the ray will go. After reflection, it will pass through the focus. So we have used rule 1 over here. What other rule should I use here? So either you can have the ray going through the center of curvature and it will bounce back over here. So you can do that, or you can have a ray passing through the focus and then parallel. So again, you can use any two which are convenient. Don't be confused that I have to use the first 2 or first and third. Any 2 rules that are convenient for you. So maybe here we can have the ray of light passing through the focus. So something like this. And if the ray of light passing through the focus, it will become parallel to the principal axis. So we can draw it something like this, parallel to the principal axis. So after reflection, that's where the ray will go. So good question. You guys should draw both the rays from the top of the object, not from the bottom, right? So there you can see, and here the object is kept beyond the center of curvature. So where are we finally getting our image? So this is the top of the object A. So the point where these rays intersect, what do you think is this point? Is it the top of the object or the base of the object? Since the rays are coming from the top of the object, this better be the top of the object, not the base. So let's mark that as A dash. And where will the base lie? So if I want to draw the image, so this top of the object, this is the top of the image, A dash, right? And why have I marked A dash? Because it is the image, it's not the object. And now where will the base lie? It's very simple. You just have to join this to the principal axis. So this point, A dash is the top of the image, and this is B dash, the base of the image. Done. So can you guys see? We have got our image here for a concave mirror, where we use rule 1 and rule 3. As simple as that. If you use rule 2, you would also get the same thing. Of course, my diagram is a bit rough here, but you will have the same ray passing through the center of curvature, and it will again give you the image at A dash. Now, one very important thing, when you guys draw the ray diagram, it is also important to write the properties of the image. So can you guys tell me what are the properties of the image here? So clearly the image is inverted, and can you see that the image is a real image because it is formed due to the real intersection of rays? Do you guys agree? So this is clearly a real and inverted image because the rays are really meeting to form this image. What other thing we can see here? The second property we can say is the image larger, smaller, or same size? So if you look carefully, you can clearly see object AB is larger than our image A dash, B dash, and please remember to label it, right? A dash, B dash, okay? Try not to draw the image as dotted. Sometimes it's shown as dotted. I like to draw it as a solid, right? Just mark it as A dash, B dash. So you can clearly see it is smaller. So we say smaller means diminished. So it's smaller in size, we can see it is a diminished image. And the final property is, what is the position of the image? So when the object is kept beyond the center of curvature, you can see image is formed between focus and center of curvature. So we can say it is formed between focus and the center of curvature. So that's where we can see the image is produced. Is it important to write the properties? Typically yes. If your school teacher says no, it's fine just to show the diagram. Usually the teachers also like to write the properties of the image formed. You don't have to draw the rays from the base of the image object, because if you just draw this ray, it is going to bounce back and go here. That is why the base is formed here, right? So do not show or draw the rays from the base. Just drawing it from the top of the object is enough. So that's why we said that, there are different types of images, real images, virtual images. So make sure you guys write the property as we had discussed last time. Real images can be taken on a screen, and real images are always inverted and the light rays actually meet. So like we saw in the diagram here, so this is clearly real image and it is inverted, and the light rays are actually meeting to form our image. It is not being produced backwards. Whereas in a virtual image, it cannot be taken on a screen. It is upright, that means it is erect, and light rays appear to meet. They do not actually meet. Let's try another concave mirror question. This time we have moved the object beyond center of curvature. This time the object is placed between the pole and the focus. So now can you guys draw the ray diagram and try to predict where the image will be formed? Of course, you can learn the different cases and learn what do you expect to see here. But first let's practice these ray diagrams. So again, remember, you need only two rules and draw the rays from the top of the object. Use only two out of the first three rules. So let's try it out, whichever one is convenient for you. So here you can see this is our center of curvature, this is the pole, and focus is exactly between P and C. So when we draw the rays, what does it look like? Again, we can go for the simple ray, which is a ray parallel to the principal axis will pass through the focus after reflection. So let's do that. Ray parallel to the principal axis, after reflection it passes through the focus. So there, I have used rule number 1. What else can I use, guys? Rule 2 or rule 3, what do you guys suggest here? So rule 3 looks a little strange because I can't have the ray passing through the focus, it's going outside the mirror. So maybe I can try rule 2. So for rule 2, what we can do is, again the ray is not passing through center of curvature, but maybe I could take a ray which is coming through the center of curvature, right? As if appearing to come from there. So if we had a ray like this, we know that after reflection it will bounce back. Do you guys agree? So ray which is targeted towards the center of curvature simply bounces back here. So after reflection the ray will become like this. Does this make sense? So great question. We are tempted to use rule 4 over here. We are tempted to do that. But what did I say? Avoid rule 4 because it means measuring angles, drawing angle of incidence equal to angle of reflection, and there are chances of errors there. With the protractor you have chances of errors. So please avoid using rule 4. Only use it if it's a direct question or if you run out of ideas. But no, you should not be using rule 4 because protractor measurements are inaccurate, so your diagram can go inaccurate. Okay. So what is happening over here? In this concave mirror, you can see these are the two rays of light. And again, I know it's not looking like a perfect diagram, so let me just improve this ray here. Hopefully that looks better now. So what you can see here, these rays are moving further apart, right? So they are diverging. So where will the image be formed if the rays are diverging out like this? So now I need to trace them back. So let's produce them backwards. So this ray will go like this, and this ray will produce backwards, and maybe they'll meet somewhere over here. Let's say they meet at this point. So very good, the image is going to be formed behind the mirror because here they are not converging, they are diverging. The reflected rays are moving away, right? So they will finally go ahead and meet over there. So now if this is our object AB, where is our image formed? Behind the mirror. A dash, B dash. Remember I said where the rays meet, that is the top of the object A dash. You just draw a straight line to the base and there you have your B dash. Okay. So now what are the properties of this image? Can you guys tell me? Again, you can learn the properties or you can just easier is observe it from the diagram. If you have drawn the diagram, you just follow your diagram and write down the properties, because you can't draw a diagram and write some different properties. You can't say this is inverted. You can see the image is erect here. So let's write down the properties here. So image properties. So first image property is, it is clearly, is it real or virtual? It is clearly virtual and upright. It is not inverted. So first property, you should decide real or virtual. It is virtual and upright or virtual and erect. And clearly it is virtual because it is formed by producing the ray backwards. They are not actually meeting. We have made them meet. It's behind the mirror. So clearly virtual image. Second point, is it size, right? Is it same size? Is it diminished, magnified? So clearly you can see this image is magnified, much enlarged, right? So clearly we know that the image is magnified, it is enlarged. And what about the location? So you don't have to write anything related to P, F and C. You can just say it is formed behind the mirror. So image is formed behind the mirror, as you can see here. Again, let's try this question, where the object is exactly at the center of curvature for a concave mirror. So can you guys see, it is exactly at our center of curvature of this mirror. And again, to get it accurate, make sure these distances are equal, right? If this is 3 centimeters, this also should be 3 centimeters. So how do you do this one? So one, of course, we can again use our rules. So we can go for, so in the ray diagram, if you use your ray parallel to the principal axis, it will pass through the focus. Again, ray passing through the focus will become parallel to the principal axis. And you can see the image, my image at least, is formed somewhere here. Is this the correct answer? So I used all the rays correctly and I got to this answer. But if you do this in the exam, even though you used all the correct rules, you will get it wrong. Why? Because this one is a very tricky one. Even if you try to draw the diagram very accurately, small errors will happen, because we know there's actually a cheating trick here. We know that if it's a concave mirror and the object is placed at the center of curvature, where will the image be formed? Exactly at the center of curvature, and it will be the same size. So you can first cheat here, draw your image and then you draw the rays. Okay, don't tell the secret. Okay, so first, but all teachers teach the secret, so now it's no longer a secret. Make sure you guys draw the image first, same size, so measure the same height as the object, draw it at the center of curvature, then you draw your rays. So that way you'll never go wrong. Okay, so I'm going to erase all of this. This is all wrong, and let's restart now with the cheating technique. So I'm actually, cheating doesn't mean you're cheating from your friend, right? Don't do all that. This is your smart technique. So the smart trick here. So first, draw the image same size as the object. So this is our object here. Let's say this is length 3 centimeters. So please draw the image exactly at center of curvature with the same length. Now please draw your rays. So you know that if you draw the ray parallel to the principal axis, after reflection it's going to meet here. So now you can join these guys. So that's my ray, and then ray passing through the focus. After reflection, we know it's going to go through this point again. So there maybe again I have to do some cheating tricks there to make it match. Again, I'm drawing a freehand diagram on the digital board. For you, it will be much easier when you do it on pen and paper. But this is the trick, that make sure your image is same as the object size and it's at the center of curvature, and there you get the diagram. And clearly here you can see image properties are going to be real and inverted. It's going to be same size as the object, and then we know it's going to be formed exactly at the center of curvature. So those are the properties. So decide real, virtual and inverted, upright, right? What is the size and then the position of the image. Let's try a convex mirror. So we have been doing concave mirrors till now. Convex mirror, let's try. So let's say the object is kept here in front of the mirror, and this is our pole, focus and center of curvature. So again we are going to use the rays from the top of the object. So this is our object AB. So first let's start off with the ray parallel to the principal axis. So after reflection we know it's going to pass through the focus, or rather it appears to pass, right? Because it cannot go through this way. So we trace it back like this. So this is our reflected ray. And then let's say we have another ray which is aimed towards the center of curvature, but after reflection it will go back. So it will retrace its path. So there you go. So where the two rays meet, that is our top of the object. So where is the top of the object? Because they're reflected off this way, they are meeting actually behind the mirror. So here you guys can see this is going to be the top of the, sorry, not object, top of the image. So our image is going to be something like this, A dash, B dash. Okay. So can you guys see? The image is formed not at infinity, it's formed behind the mirror because it's a virtual image. Of course, because these rays are diverging. So we produce the reflected rays backward and it meets behind the mirror. So what are going to be the properties of this image? Always first question, real or virtual, and similarly erect or inverted. Clearly you can see it's a virtual image formed by retracing, and obviously it is upright also. So virtual and upright, or virtual and erect. Similarly, is it magnified or diminished? We know convex mirror always forms diminished, and as you can see it is smaller in size. And how about the position? You can simply say between P and F, or you can say behind the mirror. So here, since it's located between P and F, let's write that down. So between P and F and behind the mirror, there you can see. So please remember to use these things, right, to write the properties like we discussed, real, virtual image. So always ask yourself when you're writing the properties, is it real or virtual? Similarly, real images are always inverted, virtual are always upright or erect. Next, you should write that what is the size, same size, diminished, magnified. Magnified means larger. And last is the position of the image. So make sure you write these properties for every image. So there I showed you all the tricks of how to draw the ray diagrams for concave and convex mirrors. So once again, make sure you draw those points P, F, C. The focus should be exactly in the center. Use your compass like we discussed last time to draw the mirror, and just use 2 out of the first 3 rules. Please avoid that pole rule, and random ray was just to show you if they ask you to complete a ray diagram, means just not to find the image, if they just ask for some random diagram. But these are the important rules to use, 2 out of the 3, and if you use them how I've taught you, you will definitely get all your diagrams correct. And make sure you draw the arrows for the light rays and label P, F, C, A dash, A, B, all of those should be labeled. Okay, so please follow these tricks and get your diagrams perfectly correct. And do check out the other courses on our website. We have physics, chemistry, biology and maths for CBSE class 8, 9 and 10. So guys, if you haven't taken the other courses, do take them and do share it with your friends. For ICC students, we are having physics, chemistry, biology and maths courses as well for classes 8, 9 and 10. And if you want to learn coding, we have Python programming, we have Java coding. These are awesome programming languages, and we have physics and chemistry for the Cambridge IGCSE. So make sure you share out our courses with your friends. Subscribe to our YouTube channel. You can also follow us on Facebook and Instagram. So stay connected and keep learning.